Alright, our last and final section in 1.8 is the quadratic inequality. They're similar to the quadratics we just did, okay, but there's one little twist on it, alright? So our basic form, just like before, is ax squared plus bx plus c, okay, and it's 0. However, it's an inequality, so it can be greater than, less than, greater than or equal to, and less than or equal to 0. Okay? Very similar to the original, we're going to still factor, okay? We want to find solutions, though, that kind of fall in a range. Okay, all inequalities seem to have a range of numbers that we can use. Okay, to find these ranges, we're going to have to set up what we call a sign chart. Now, because it's greater than or equal to 0, we only have to look at the signs. Later, we're going to do it with true and false when we have to see when something is greater than something, or so on and so forth. We could also test it here, but we'll see. Maybe I'll do it for one. Because we are finding zeros, though, that's what we need to find first. That is where the only place numbers will change from positive to negative, or negative to positive. Okay? Think about it. A graph. Here's a quadratic. Remember, it's a parabola. It's only negative. It's above the axis here, it's positive, then it's negative down here, and then it hits a root, which we can find from our last thing, and then it's positive again. Right? So our goal is to find out the ranges where the graph is above or below something. Right? So, warning, do not assume zeros are sign changes each time. Think about a graph that does this. Ooh, and just touches it. Okay, it's always above it, even though it just touches it. That's where the problems can run into. Okay? So, the procedure. Put the equalities in standard form, aka get it equal to 0, just like before, or less than, greater than, and so on and so forth. Find the solutions to that equations. Okay? So you're going to find it just like we did before. The extra step is we're going to set up our sign chart and test these intervals. Okay? And then we're going to list the intervals that satisfy the inequality. Okay? By the way, for all of you, that's Kirby. Okay, one of the Nintendo's most famous thing, big yellow puffball, eats a lot, has lots of games, very cheap in Smash Brothers. That's another story. All right, so let's start with the first one here. Already got 0 on one side, so we're going to treat it like an equal sign. Think of it that way. If I did that, it factors. Okay, this one factors to x plus 3 and x minus 5. Okay, remember there? So you get x equals 3, x equals 5. Now, what we're going to do is establish our sign chart. Our sign chart has our roots on it. So, oops, that's a minus 3. You put minus 3 and a plus 5 on there. Our goal is to test where it is positive and negative. If we do that, since it's less than 0, we're looking for negatives. We want to see the region that's negative. So the problems there is, instead of actually finding true or false, that's how some people do it. We find where it's true, plug in numbers to see where it's true. We're just going to see what the signs are. Now there's two ways to do it. You can plug it in the original, or you can plug it into the factored form to see what happens. Always plug in 0 if you can, if it's not a root. You cannot plug in a root. If you plug in a root, you're going to get 0, and we don't know if that's negative or positive. So be aware of that. Okay. So, step 1, we're going to try some spots. Let's try 0. I always plug 0 in the original because it's easy. 0 minus 2 times 0, which is 0, minus 15. It's negative. So I'm going to put negative right there, the minus signs. Okay. If I plug in a number greater than 5, try 10. You can do 10 squared, which is 100, minus 20, minus 15. Oh, it's minus 35. It's positive. It's easier to plug in here. You only have to know the signs. You don't have to actually know what the number comes out. This is a positive, right? When you put 10 plus 3, that's positive. 10 minus 5 is 5. It's a positive. Positive times positive is a positive. So use that to your advantage. Just like negative 5. If I do negative 5 in here, this is negative 5 plus 3, which is negative 2. Negative 5 minus 5 is a negative 10. Well, negative 5 times negative 10, I don't really care, but I know it's positive. Okay. So now my next question is, what is the question asking? We're looking for less than 0. So we're looking for a region that is negative. Okay, the region that's negative is this one right here. Okay, so we just want to write our solution set as everything between there. Remember, it can't be anywhere else because that's where we switch our signs, and we did that with the graph showing it. So where's x got to be? This is where our interval notation comes in. Because it's not equal to, I can't be negative 3. So it's from negative 3 to 5, using parentheses. Alrighty, so perfect. Move on to the one on the right. X squared minus 4x plus 4 is greater than or equal to 0. Okay? First thing we do is get it all on one side. Factor. X. Things that factor. How about minus 2 and minus 2? X minus 2 equals 0. X equals 2. X minus 2 equals 0. Oh, look, it's the same. We only have to put 1 on our sign chart then. So, there's 2. Now we test them. I plug in 10. I plug it into this statement here. One where it's greater than or equal to 0. 10 squared is 100. 100 minus 40 is something positive plus something is positive. It's positive. Try 0. 0 minus 0 plus 4 is positive. Ooh. We're all positive. We want it greater than or equal to 0. Okay? If you do that, well, I want all the ones from negative infinity to 2, but 2 to infinity. That's the set of all real numbers. X is everything. Pick a number, it works. It goes from negative infinity to infinity. Okay? Now, by the way, if you tested in the original, you can't look for pluses and minuses. You gotta look for true falses. So we plug 0 in, you get this 0 greater than negative 4, and you get true. That's why it works. So that's a good region. And if you tried 10, 10 squared is 60. Is that greater than or equal to 4? That's true as well. So that's the difference. All right, a couple more to go. Lots of 2's. Got to get the inequality less than or equal to 0, greater than or equal to 0. So subtract 2. 2x squared minus 2x minus 24. Minus 2 there. Remember that. It's less than or equal to 0. Going to factor 2 out. 2 times x squared minus x minus 12. Less than or 0. Again, you're solving for roots, so you don't have to worry about the 2 that much. This factors to x plus 3. X minus 4. Set them equal. X plus 3 equals 0. X minus 4 equals 0. You get x equals minus 3. X equals 4. Alright, sign chart time. So, there's my sign chart. Put my roots on there. Negative 3, 4. Start testing. Plug in 0. I'll plug in 0 right into this one right here. 0 minus 24, that's negative. 10. I don't want to. 10, let's plug it into this one. That's 13, that's positive. 10 minus 4 is 6. It's positive. Positive times positive is positive. Most of the time people are like, oh, does it go plus minus plus? Yeah, and that's why I said in the last one we had to check to make sure. So don't always assume. We all know what happens when you assume. Let's try negative 10. Negative 10 plus 3 is negative 7. Negative 7 minus negative 10 minus 4 is negative 14. Negative 10 is negative is a positive. So far so good. And then we get right here our solution to be that range right there. However, can I include the endpoints this time? It says equal to, so the roots are included. So negative 3 to 4. All right. So far so good. Now, I'm going to change the problem because this one's not as much fun. Let's try x squared is greater than x plus 6. Yeah, I get everything over to the left side. I always get it greater than or equal to 0. It's the easiest way to do it. X squared minus x minus 6 is greater than or equal to 0. All right. Factor it. X minus 3. X plus 2. X equals 3. X equals minus 2. Notice how they're always opposites. So now all I need is my sign chart. Minus 2, 3. Let's test some points. That's 0. It's always in there. 0 minus 6. It's a negative. Alrighty, try 10. 10 squared is 100 minus 10. Oh, that's positive. Also, positive times positive is positive. Which are negative 10, that's a positive 100. That's a positive 110. Minus 6 is 90, 104. That's positive as well. Now this time, though, I changed the problem. If you look, it's greater. I need things that are above 0. So that's that region there and that region there. All right. If it's can't equal to, can't be the roots, so it's going to be parentheses. So this region is from negative infinity to negative 2, all parentheses. This region is from 3 to infinity, all parentheses. Put them together, and that's our solution set. X has got to be in there. All right. We have this one right here, already set up for us, so it's nice and easy. Let's try and factor x minus 1, x minus 1, that factors 2. X equals 1, x equals 1. Ooh, it's one of those that has that nice single point. Try 0. 0 minus 0 plus 1 is plus. Okay. Try 2. 2 squared is 4. Minus 4. 0 plus 1. Oh, it's plus. It's plus everywhere. All right. It asks if it's greater than or equal to 0. All right. Can I include this point here? Yep, because it's equal to. So x is everything. X is an element of the real number, so from negative infinity to infinity. Right? We have our final question. List all the inner series solutions. All right? So we actually have to solve it and see where our range is and then list the integers. Okay? First step is to subtract 15. It's less than 0. Factor x plus 3, x minus 5. Okay, I'm getting better at this. X plus 3 equals 0, x minus 5 equals 0, x equals minus 3, x equals 5. Sign chart, yes, we still need to do it. Negative 3, 5. Test 0. Does 0 work? 0 minus 0, minus 15, minus. Try 10. 10 squared is 100, minus 20, minus, that's 45, that's still 65, it's positive. Negative 10 squared is positive, and that's positive. Now that outranks it, it's positive there. So this is the range we need, all right? So this one said list the integer solutions, follow the direction. So we want the numbers between negative 3 and 5, but we can't include the endpoints because it's not equal to. So name the numbers that are between negative 3 and 5, not including them, that are integers. Well, it's just negative 2, negative 1, 0, 1, 2, 3, and 4. Those are the possibilities. Okay, so a little more work. Watch your sign charts, okay, and you have your answers. Make sure when you have inequalities, you do a sign chart. That's going to be big. Okay, later we'll do a true-false chart. It's the same thing, all right? You guys keep working, and we're done with Chapter 1. See you later.